Hello. So today we're going to talk about how to combine ideal gas law and stoichiometry. And so a lot of times we are going to do stoichiometric problems that involve gases. And basically what it comes down to is it comes down to what pieces you have first and which pieces and variables you have enough of to answer the question. Okay, and so sometimes you use the ideal gas law first to find moles of a gas so that you can take that number of moles of a gas and plug it in to find moles or grams of another compound in the equation. Other times you will have enough information to use the stoichiometry stuff first, and you will then determine how many moles of gas are produced and then find either the pressure or the volume or maybe the temperature of that gas to fit those criteria. And so really you just have to use your skill set, and you just kind of got to figure it out and label out your pieces and see what you got and what you can do first. Okay, so the example that I'm going to use for that is going to be about car airbags, so safety airbags. They are filled with nitrogen gas. That nitrogen gas is produced through a decomposition of a compound called sodium azide. Chemical equation for that is 2NaN3. This is a solid. Breaks down into 2 moles of sodium, also a solid, and it spits out 3 moles of nitrogen gas. Okay, so 2NaN3 is a solid, makes 2Na as a gas, that should be a solid, sorry, and it makes 3 moles of N2 as a gas. Okay, so now if an airbag has a volume of 36 liters, okay, so I have a volume right here, so 36 liters, that's a volume, and is filled with nitrogen gas at 1.15 atmospheres, there's a pressure, so I have a pressure here, and I have a temperature. Okay, how many grams of NaN3 needed to be reacted to get to that point? Well, if I look at ideal gas law, PV is equal to nRT. So if I underline the parts I already have a pressure, I already have a volume, and I already have a temperature. So what I'm going to do is I'm going to solve this to find the number of moles of gas produced or needed, and then I'm going to take that number of moles of gas and I'm going to use my stoichiometric pieces from here to get back to here to get back to grams. Okay, and so that's how we're going to do this one. Okay, so here we go. So I know that I want to get to moles of our gas. So PV equals nRT is what we're starting with. We're going to rearrange that to get moles of gas by itself. Okay, so N is going to equal pressure times volume divided by R times T. Okay, so now we're going to put our numbers into that. So our pressure is 1.15 atmospheres. So that's that number. Our volume, we already circled it right here, is 36 liters. Okay. My R value is the R value that has atmospheres in it. So this is going to be 0.08206 liters times atmospheres divided by mole times K. And the last thing I got to do, and you can't see my horizontal line very well anymore, is we have to have our temperature. Now my units for temperature in my R value are K, so we have to convert 26 degrees Celsius to K. 26 plus 273.15 gives me a value of 299.15 K. Alright, so now we take that number, we multiply them all out, 1.15 times 36, enter, divide by the quantity, 0.08206 times 299.15, close parentheses, enter. Your calculator should have spit out a number that looked a lot like 1.69 moles of nitrogen. Okay, so now we're not there yet. In the end, I want to know grams of the sodium azide. So my goal is to determine grams of sodium azide, but now we have a starting point that we can use here to back work to get here. And so I'm going to take this number right here, I'm going to take my 1.69 moles of N2, I'm going to make that a fraction, I'm going to put it over 1. Now I know that for every 3 moles of N2 that gets created in this chemical reaction, and again, you'll notice this is our stoich skills. We're going to have our moles of N2 opposite each other so that the unit cancels off. But for every 3 moles of N2 that I create, I needed to start with 2 moles of NaN3. So 2 moles of sodium azide, NaN3, over 1, or over 3. Okay, and now the last thing we got to do is we want to get this into grams. And so I know that 1 mole of sodium azide, and so do you, has to have a mass. We get that mass from your friend and mine, the Ultimate Party Planning Guide, the periodic table. We add up 1 atom of sodium, 3 atoms of nitrogen. We should get a mass right around 65.0 grams, because that was what I got. All right, so moles of N2 cancels, moles of NaN3, moles of NaN3 cancels. We are left with units of grams of sodium azide, which is what we were hoping to get. And so now all we have to do is do the math. So 1.69 times 2 times 65, enter, divide that by 1 times 3 times 1. The amount of grams of this stuff that we should be starting with, or that we need to start with, should be around 73.2 grams of NaN3. And so that's how that works. So there's our answer. And in this instance, like I said, we were able to use ideal gas law first because we had enough of the variables. If you're doing one of these problems and you label it out and you look through it and you don't have enough variables to use ideal gas law first, well then obviously you have to make sure that you're going to use the stoichiometric stuff first, so whatever this is, to end up in the moles of your gas to take those conditions to figure out what it is you need to find. The other thing that I would be very cautious about is, or be very honest to you guys about, make sure that you're paying attention to your phases of matter, because if you're not paying attention to your phases of matter and you apply gas law to something that is a solid in this equation up here, then you're going to have problems. And so you got to make sure that that's not going to happen. Okay, so pay attention to your phases of matter in your equations so that you don't end up having some sort of a concern or a weird thing happen because you're applying ideal gas law to something that's not a gas. So that's all I got. The only thing you can really do about doing this stuff is just practice and make sure that you look for the right parts and the right pieces and apply it as you need. So there we go.